So this is 3.2, which is the graph of a function. Just a quick reminder from 3.1 that an easy way to determine if a graph is a graph of a function is with the vertical line test. You have your vertical line. If it touches once, it's a function. If it touches more than once, it is not a function. Okay. That being said, we can kind of move into our new stuff. So if a point x comma y is a point on your graph, another way of saying that is y is the same thing as f of x. So you could say this is x comma f of x. You can also rewrite any point x comma y in function notation. So if you have a point negative 2 comma 7, then in function notation that would be f of negative 2 equals 7. Remember that the thing in the parentheses is an x, so this negative 2 in the parentheses is an x. The 7 represents the y. Similarly, if they told you f of 5 equals 8, then they're telling you x is 5, y is 8. So the point 5 comma 8 is on your graph. This is really nice because it allows you to get information from a graph, and it also allows you to take information that's given to you as function notation and transfer it to points that you can plot on a graph. So let's look at an example of this. So it says, let f be the function whose graph is given below. So this is a graph here of f. Part A asks, what are f of 0, f of 3 pi over 2, and f of 3 pi? Well, f of 0, remember this 0 is an x, so I want to go to where x is 0. X is 0 right here. My point is here at 0 comma 4. So the x is 0, which means the y is 4. All right, f of 3 pi over 2. It's the same kind of thing. 3 pi over 2 is an x, so I want to go to where my x is, or 3 pi over 2, which is this point right here. My y value there is 0. Oops, sorry, let me finish the 0 off. All right, and then lastly, they ask us about f of 3 pi. Well, again, remember 3 pi is an x, so go to where the x is 3 pi, which is this point down here. Look for the y value, which is negative 4. Part B. Part B asks us, what is the domain of f? When we look at the domain of a graph, we always go with the x values from the left side of the graph to the right side of the graph. So where do our x's start? They start at 0, and we do include the 0 because there is a point there at 0 comma 4. And then we start moving to the right, moving to the right, moving to the right, and we get to this furthest point to the right. The x there is 4 pi. And we do include the 4 pi because, again, it is a point on the graph. All right. Part C asks us, what is the range of f? Well, remember that range refers to y values. And when we do the range from a graph, we go from our lowest y value up to our highest, so from the bottom to the top. So our lowest y values are down here, and the y values are negative 4. And again, we include that y value because we do have points that are there at negative 4. And then we start climbing up. And so we climb up, up, up. The highest y value we get to is up here, which is at positive 4. And again, we include that positive 4 y value because we do have several points that have that y value of 4. All right. Part D asks us to list all the intercepts of f. So let's start with x-intercepts. Remember, x-intercepts are where you cross or touch the x-axis. That happens here, 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 and here. So we actually have 4 of them. Pi over 2, comma 0. 3 pi over 2, comma 0. 5 pi over 2, comma 0. And 7 pi over 2, comma 0. My print is kind of ended too much early. All right. For y-intercept is where you cross or touch the y-axis. So we look along our y-axis. It only crosses or touches right here at this point, which is 0, comma 4. All right. Part E. Part E asks us, how many times does the line y equals 2 intersect the graph? Well, what kind of graph is y equals 2? From what we did a couple sections ago, we know y equals 2 is the graph of a horizontal line. So I'm going to go to where the y value is 2, and I'm going to draw a horizontal line. How many times does this blue line intersect with the horizontal line? 1, 2, 3, 4. So we can say 4 times is how many times it intersects. Right, letter F. Letter F asks us, for what values of x does f of x equal -4? Well, remember up here we just said that f of x is the same thing as y. So this is literally saying y equals -4. So it's asking us, where is the y value -4? Well, there's a y value -4. It happens here and here. So that's at x equals pi and 3 pi. Those are the two x's where the y value was -4. All right, our last part, part G, asks, for what values of x is f of x greater than 0? So I'm looking for f of x greater than 0. Now remember, f of x is the same thing as y. So it's asking you where the y is greater than 0. Now greater than 0 means positive. So it's asking you where is the y value positive. So what I'm going to do is I'm just going to go in and circle these places. So the y value is positive here. The y value is positive here. And the y value is positive right here. Now, because these are not distinct points, these are intervals. Meaning it's positive from here to here, it's positive from here to here, and it's positive from here to here. So we're going to write our answer as intervals. Now when we do this, we use x's because the question asks us what values of x. So our intervals are going to be in terms of x. So let's start with this one. Where does this interval start? Right here, and the x value right there is 0. Now we can include the 0 because the y value there is 4, and 4 is greater than 0. 4 is a positive number. So we can include that point. All right. This interval ends down at this point, which has an x value of pi over 2. Now can I include the pi over 2? I cannot, because the pi over 2 has a y value of 0, and 0 is not greater than 0. So I cannot include that point. So there's my first interval, from 0 to pi over 2. My second interval is right here. It starts at this point, which has an x value of 3 pi over 2. Do I include the 3 pi over 2? Well, no. The y value is 0, and again, 0 is not greater than 0. So I do not include the 3 pi over 2. And then this interval continues to go until I get to this point right here. This point right here, the x value is 5 pi over 2. Do I include the 5 pi over 2? Well, if we look at the y value is 0, so no, we do not include it. And then we have one more interval, this interval right here. It starts at this point, which is 7 pi over 2. Do we include the 7 pi over 2? Well, if we look at the y value, 0 is not greater than 0, so we do not include it. And then this interval ends here at this point, which has an x of 4 pi. Do we include the 4 pi? Well, if we look at the y value is 4, and 4 is greater than 0, so we can't include. And so there are our 3 intervals where the y value, or the f of x value, is greater than 0. Okay? So there's how that one looks. We can also do some of these things with equations. So example 2 says the average cost, C bar, per computer of manufacturing X computers per day is given by the function C bar of X equals 0.56 X squared minus 34.39 X plus 1212.57 plus 20,000 divided by X. And they ask us to determine the average cost of manufacturing. For part A, we are manufacturing 30 computers. Well, computers, they told us, is x. It's x computers. So when they tell us 30 computers, they're telling us let x be 30. So just replace all of the x's with 30. C bar of 30 equals 0.56 times 30 squared minus 34.39 times 30 plus 1212.57 plus 20,000 divided by 30. And then we're going to go to our calculator. So we have 0.56 times 30, that's getting squared, minus 34.39 getting multiplied by 30, plus 1212.57 plus 20,000 divided by 30. And so there's our answer. Now, because this is a cost, this is money, so we're only going to go to 2 decimals. So this is going to be 1351. And how many cents is that? 54. So that's the cost if they manufacture 30 computers. All right, part B asks, what about if we do 40 computers? Well, that's telling us let x equal 40. So I want to find C bar of 40. And it's going to look exactly the same as this. It's just instead of having 30 here, here, and here, I'm going to have 40. So rather than writing the equation, I'm just going to go to my calculator. And I'm actually going to just type it in really quick. So 0.56 times 40 squared minus 34.39 times 40 plus 1212.57 plus 20,000 divided by 40. And there we go. So 1232.97. It's 32, right? 1232.97. So there's the cost if they manufacture 40 computers. And then part C asks what if they manufacture 50 computers. So again, we have x equals 50. So we'll have C bar of 50 equals, and then we just go to our calculator. 0.56 times 50 getting squared minus 34.39 times 50 plus 1212.57 plus 20,000 divided by 50. So that gives us 1293.07. So here we go. So there's our average cost for doing 30 computers, 40 computers, and 50 computers. So it's pretty easy. Just take the X they give you and plug in. Now here they gave us computers, so we knew that was X. If they had said the cost is 2,000, then all we'd have to do is plug 2,000 in here for the cost and then solve for X, and we could figure out how many computers were made at that cost. So it just depends. If they give you an X, you plug into X. If they give you the Y, you plug in for the F of X, or in this case, C bar of X. Okay? All right, then let's look at our last example. So this one asks us to consider the function f of x equals x plus 1 over x plus 2. Part A asks us to find the domain. Well, remember from our previous set of notes that there are 2 domain restrictions we look at, fractions and square roots. This is not a square root, it is only a fraction. On fractions, the restriction is that the denominator, the bottom, cannot equal 0. So x plus 2 cannot equal 0. So if we solve that for x, we move the 2 over, we get x cannot equal
negative 2. So our domain would be negative infinity to negative 2, union negative 2 to infinity. Okay. Part B. Part B says, is the point 1, 1/2 on the graph of f? Another way of saying that is, does f of 1 equal 1/2? Well, the easy way to check that is, let's figure out what f of 1 would be. So take 1 and plug it in for all of your x's. So you have 1 plus 1 over 1 plus 2. 1 plus 1 is 2. 1 plus 2 is 3. So we get 2 over 3. So our answer is no. The point 1, 1/2 is not on the graph. The point 1, 2/3 is. Now, you don't necessarily have to write all those words, but I just want you to understand that what we proved is that the point that is on the graph is 1, 2/3, not 1, 1/2. Okay. All right. Part C says, if x equals 2, what is f of x, and what point is on the graph of f? So we're just going to take 2 and plug it in for all of our x's. So we'll have f of 2 equals 2 plus 1 over 2 plus 2. 2 plus 1 is 3. 2 plus 2 is 4. So there's what we get when x is 2. Now what point is on the graph? Well, the x was 2 and the y was 3/4. So 2, 3/4 was on the graph. All right. Part D says, if f of x equals 2, what is x, and what point is on the graph of f? Well, remember, f of x equals 2. F of x is the same thing as y, so this is really saying what the y equal to. So plug in 2 here for f of x. 2 equals x plus 1 over x plus 2. This is a fraction. To get rid of the fraction, we're going to multiply both sides by the denominator. So we'll multiply both sides by x plus 2. Here on the left, 2 times x is 2x. 2 times 2 is 4. Over here on the right-hand side, the x plus 2's can cancel out. And so I just have x plus 1. If I subtract the x over, 2x minus x gives me just x plus 4 equals 1. And then I subtract the 4 across, so x equals 1 minus 4, which is negative 3. So there's what the x is, but they also asked us what is the point on the graph. Well, the x was negative 3, and the y value that we started with was 2. So negative 3, 2 is on the graph. All right, the very last part, part E, asks us what are the x-intercepts of the graph of f, if any, what point or points are on the graph of f.
Well, remember from earlier in this unit,
we talked about how for x-intercepts we make the y be 0. So when you have an x-intercept, the y is 0. So plug in 0 for your f of x for your y, and just solve. So 0 equals x plus 1 over x plus 2. Again, we have a fraction, so we're going to multiply both sides by the denominator, by that x plus 2. On the left-hand side, 0 times x is 0, and 0 times 2 is 0, so we just get 0. Here on the right-hand side, the x plus 2's can cancel out, so all I have is x plus 1. And then we can subtract the 1 across, and we can find that x equals negative 1. So there's what x equals, and then when it asks us what points are on the graph, well, the x is negative 1, and we know that we plugged in 0 for the y, so it's going to be negative 1, 0. That would be the x-intercept on the graph. And that is it for this set of notes. As always, if you have any questions, feel free to shoot me an email or use the Ask My Teacher feature on my Math Lab, and I'll try to get back to you.